So around project feasibility, if you heard the context, let's say I have a project wherein I'm making an initial investment of maybe 1,000 crores. Yeah. I'm making an initial investment of 1,000 crores. And the cash flows, the life of the project is 7 years. When you execute a project, you borrow money mostly and execute a project. So when you borrow money, you will be having a cost of capital. So the cost of capital which is deployed for the project, let's say it's 9% annualized interest, which also becomes your minimum rate of return that you would expect to earn on the project. Also, assume that the end of year one cash flows forecasted to be 220 crores, or rather keep it simple, 200 crores. And thereafter, this cash flows are expected to grow. These cash flows are expected to grow at, let's say, 5% annually. Okay. Well, let's keep it 8% annually, 10% annually. Keep it simple, 10% annual growth on your cash flows. So the first thing we will do is plot the cash flows. First, plot the years. So since this is a cash flow which has a useful life of 7 years, so this is a 7-year project. First, we plot the cash flows. Now, our base cash flow is given to us. Our cash flow at the end of year one is given to us, isn't it? It's 200 crores. See, what you are getting for 7 years is a benefit. What you are investing today, 1,000 crores, is a cost. And what you're getting, 200 crores at the end of the first year and then beyond, is your benefit. So here what I am doing is I am plotting the benefit. So 200 crores is to year one, and then these cash flows are expected to grow at what rate? 10%. It's given to us, isn't it? So all I need to do is the next year cash flow is the previous year cash flow into 1 plus 10%. Now, can I simply drag this? No, because 10% should be a static reference. So for the static reference, I freeze my rate and then drag it down. So this becomes my cash flows for 7 years. Now, if you add these up, just add these up, all these, you will see you're getting about 1897 crores. So you're investing 1,000 crores and you're getting 1897 crores. So ideally, mathematically, this is a good project. But the challenge is these cash flows are occurring at the end of several years. So we will have to first discount these to the present, because you are investing 1,000 crores or you're planning to invest 1,000 crores when? Today. So you can't compare apple to apple till you bring the future cash flows to the present. Okay, now how will we do that? If you remember when we did the time value of money, we saw that future value is present value into 1 plus r raised to the power of n, isn't it? So we can say that present value is future value divided by 1 plus r to the power of n, or I can say future value into 1 by 1 plus r raised to the power of n, isn't it? Now, what is this 1 by 1 plus r to the power of n? 1 by 1 plus r to the power of n is called as discounting factor. So basically, if you apply your discounting factors to your future values, you will arrive at your present values. So future value into 1 by 1 plus r to the power of n is present value. So 1 by 1 plus r to the power of n is discounting factor. It is a factor which you will apply on future cash flows to bring them to present. So the next step is therefore to calculate the discounting factors, which is 1 by 1 plus r. Now r is nothing but your cost of capital, which is 9% to the power of n. This is your n. Again, r is a static reference. So I freeze my r and drag it down. So this becomes your discounting factors. Now, what are these discounting factors? These discounting factors, when you apply on future cash flows, you will bring them to present value. So present value therefore becomes future cash flows multiplied by your discounting factors. Now what we will do, we will add up these cash flows. It will give you your present value of all cash benefits from the investment, which is how much? It is 1320. So mind you, we can't compare 1897 with 1000 because 1897 is a summation of cash flows occurring at different points in time, which is not right. So first you'll have to bring them all to a common time zone, isn't it? So what does this mean? This means that 200 crores of cash flows at the end of 1 year is equivalent to 183.49 crores today. To 354 crores at the end of 7 years is equivalent to 193.82 crores today. Are you getting the point? So we have brought all these cash flows to a common term, and if you add these up, it comes to 1320 crores. Now from this, we will reduce our initial cash outlay, which was how much? 1000 crores. So if you reduce that, you will get your NPV. So NPV becomes 1320 minus 1000, which is 320.3 crores. Are you getting it? Now we can also get NPV using the Excel function, by the way. You can also use the NPV. You can also obtain the NPV by using the Excel function. So I'm going to write here is equal to NPV. Bracket open, it asks me for the rate. Rate is 9%. It asks me for the cash flows. Here are my cash flows. Bracket close, enter. What do you get? The same value, 1320.3. From this, if we reduce our initial investment, I'm going to get the same value of NPV. Can you see that here? Hey, everybody okay? Now we can do a sensitivity test around this NPV also. Let's say I change this cost of capital to 14%. I'm just changing. See, that's the advantage of linkage. I'm just changing the percentage. Everything should change on its own. If I change my cost of capital to 14%, look what happens to your present value. It comes down to 1100. If I change it to 17%, your NPV comes down to almost same. If I bring it to 20%, your NPV becomes negative. Are you getting it? So why should we spend so much labor and effort and time to do it manually? Does Excel provide a way? Does Excel provide a way to do it faster? It does. It's called as sensitivity test, which we can use, which we can do by doing the data table. Don't worry, even if you are not getting it, you are going to get the recording of this video. So pay attention, that will be better. So what I will do here is I'll put the COC and my NP. Remember, NPV. Remember, any function has two variables, independent variable and dependent variable. So if your independent variables change, your dependent variable will also change. So you need a sensitivity test will change one independent variable at a time and examine the impact on the dependent variable. Are you getting it? So first we have to establish the relationship between the independent and the dependent variable. So I will write here, my input is my cost of capital, which I am getting from here, right? The output is NPV, which I am getting from here. So by this, I have established the input-output relationship, stating clearly that cost of capital is my input and NPV is my output. Now I will change the cost of capital by 1% and see what is the impact on NPV. So let me start with 1% and go up to 20%. So first I'll just plot the numbers, starting with 1% going up to 20%. And then I will select, please pay careful attention, don't miss this part. First, I will select the entire data table, go to data, what if analysis, there is something called as data table here. So I'll click on this data table. It asks me for two options, row input and column input. So here is where you need to make a choice. Now, are my inputs arranged in a column or are my inputs arranged in a row? My inputs are arranged in a column, cost of capital. So I'll choose my column input cell. And यहाँ पे जाके I'll put my link on that cell, जहाँ पे change करने से सारा मॉडल अपने आप change हो जाएगा, which is this cell. And I press OK, and you will see that you will get all your NPVs. Can you see that? इधर सारे NPVs आ गए, आया कि नहीं? So this is your base case. इसको आप छोड़ दो. So if you start from 1% to go up to 20%, you will see that as my cost of capital is increasing, my NPV is falling down. Is it clear? And finally, it becomes negative. Now, can you tell me what is special about these two numbers? This range that I'm highlighting here. Do you observe something when you look at this range? At 17%, you have a positive NPV. But at 18%, your NPV is negative. Which means what? Between 17 and 18%, कोई एक ऐसा point होगा जहां पे NPV is 0. That point is called as IRR, internal rate of return. At your internal rate of return, your NPV becomes equal to 0. So it's kind of a break-even point for you. And your cost of capital should never exceed your IRR. As long as your IRR is greater than your cost of capital, you will be in a positive zone. Otherwise, you become negative. So can we find out the IRR? Yes, we can. So I will find out the IRR here and see what it comes to. So first I'll just copy these cash flows here. Copy and paste it special here, because I don't want the formulas to interfere. So I'll just paste special. And mera initial investment I will put on top. Okay, and then I will say is equal to IRR. equal to IRR. Values, I take these cash flows, bracket close, enter. What do I get? 17.06%. Can you see this is between 17 and 18? It is. That's why I highlighted that range. That when the IRR, when your cost of capital is between 17 and 18, somewhere NPV becomes equal to 0, and you can see it. IRR is 17.06, and that's where your NPV becomes equal to 0. समझ में आया? Now you can also find this out. Please pay attention. Do not miss. You can also find this out by using another function which is called as the goal seek function, seeking a goal, seeking an objective. So if I go here, data, what if analysis, there is something called as goal seek. So in my goal seek, what will I do? My objective for obtaining IRR is what? Setting your NPV to what value? 0 value. By changing my cost of capital and press OK. Aha. 17.06%. And NPV has become 0. So this is another way in which you can get your NPV, which is by using your goal seek functionality. Did you get what I said? So we have obtained IRR using the IRR function, and we have obtained IRR using the goal seek functionality. Now what we can do is we can also construct a graph for this. So if you construct a graph here, recommended charts, take the scatter, you will see, and you can beautify a graph you want the way you want. So this is my NPV profile, because it plots your net present value and your cost of capital. Now, if you look at this graph carefully, please look at this graph carefully, you will see that somewhere between 15 and 20%, it is intersecting with the x-axis. That point is called as IRR, internal rate of return. So जब तक आपका IRR आपके cost of capital से ज्यादा है, you will lie in the positive NPV zone. But moment your cost of capital exceeds IRR, you will fall in the negative NPV zone. That is what you saw in the table also. तो ये वाला जो zone है, जहां पे your cost of capital has exceeded IRR, you can see that you have got negative NPV values. And ये वाला zone जो है, जहां पे your IRR is higher than your cost of capital, you have positive NPV values. समझ में आ रहा है आपको? So we have used two components of what if analysis. One is called as data table. The other one is called as goal seek. And now we will use the third one, which is called as scenario testing. So I can create multiple scenarios also out of this. So if I go to data, what if analysis, scenario manager, I can create scenarios one by one. So my first scenario will be end of year one cash flow, best case. End of year one cash flow, best case. Where did I start with my end of year one cash flow? I started here. इसका best case क्या हो सकता है? That is your changing cell. Put the best case value. Let's say the best case value is 250 crores. Then you add another scenario you call as end of year one cash flow, worst case. Again, my changing cell is this one. Press OK. Let's say this is 150 crores. Add another scenario. Right here, cash flow growth rate. Best case. Let's say this is my cash flow growth rate. My best case is 12%. Add another scenario, cash flow growth rate. Worst case. Let's say worst case for my cash flow growth rate, I'm going to get a growth of 8%. Now, mind you, when I do this, I'm going to see the NPV one by one only. एक वेरिएबल चेंज होगा क्या इम्पैक्ट है, एक वेरिएबल चेंज होगा क्या इम्पैक्ट है. What if I want to make a combination best case where I change all the independent variables in one shot? So I can write here combo best case also. Combo best. So यहाँ पे I'm going to change all my independent variables, which is my end of year one cash flow also and my growth rate also. दोनों साथ में चेंज करें. एंड आई प्रेस ओके. यहां पे वो आपको पूछेगा, दो वैल्यूज पूछेगा. व्हाट इज माय बेस्ट केस फॉर एंड ऑफ ईयर 1 250. व्हाट इज माय बेस्ट केस फॉर कैश फ्लो ग्रोथ रेट 12%. अगेन I make another one called as combo worst case. यहां पे again two cells, end of year one cash flow and growth rate. Press OK. वो आपको पूछेगा यहां पे राइट 150 फॉर एंड ऑफ ईयर वन कैश फ्लो एंड 8% फॉर growth rate. Press OK. Now I have created how many scenarios? देखो यहाँ पे 1 2 3 4 5 6 scenarios. Now I want to examine the impact of these scenarios on my NPV. So rather never ever press the show button. कभी नहीं प्रेस करना शो को. You have to press the summary button. Click on the summary. वो आपको रिजल्ट सेल पूछेगा. I am only concerned with NPV. That's my result cell. Please pay attention. I will press OK. That's it. All my scenarios are now there on the screen. You can check. The 6 scenarios that we created are here. Now this is your, ये जो यहाँ पे है ना, this is your base case. This is the one which is current, if you remember. अब ये एक एक करके देखो. This is एक एक करके we are checking. This is for cash flow. If your cash flow becomes 250, what happens to your NPV? If your cash flow becomes 150, what happens to your NPV? Same way for growth rates. If my growth rates become 12%, what happens to your NPV? If my growth rate becomes 8%, what happens to my NPV? आप देखोगे कि growth rate causes more sensitivity to NPV than your first year cash flows. The range is much wider. है कि नहीं? Or maybe, yeah, it depends on the volume also. And see, this is combination. यहाँ दोनों साथ में change हुए. This one is combination, and you can see what is the impact if both of them change favorable or both of them change worse in one shot. तो क्या NPV होगा बेस्ट केस और वर्स्ट केस में. सो ये जो मैंने ग्रीन, ये जो मैंने येलो में हाईलाइट किया, दिस इज योर बेस केस. द वंस दैट आई हैव हाइलाइटेड इन ग्रीन एंड पिंक, दिस इज नॉट एक्चुअली सिनेरियो टेस्टिंग. दैट इज सेंसिटिविटी टेस्टिंग ओनली, बिकॉज आई एम चेंजिंग वन वेरिएबल एट अ टाइम एंड सीइंग द इम्पैक्ट ऑन एनपीवी. लेकिन ये जो ग्रे में हाईलाइट किया है, यहाँ पे आई एम चेंजिंग मल्टीपल वेरिएबल्स एट अ टाइम and seeing the impact on NPV. That actually is called as scenario testing. समझ में आया? Okay. So in this video, therefore, we covered what? You learned how to calculate NPV using the Excel function and using the tabular approach. You learned how to calculate IRR using the Excel function and goal seek function. You did a sensitivity test between COC and NPV using data table. You also constructed a graph which was downward sloping. You also found out IRR using the goal seek function, and we also did scenario testing. One case, but you learned so much in one shot, right? So that is the idea of thematic learning actually. Okay. Hope you liked it. Thank you. I'm ending the video now.